Imagine stepping onto a scale and seeing a smaller number just because of where you're standing on Earth. No diet, no exercise, no magic, just physics. If you were standing at the equator, you'd weigh less than if you were at the North or South Pole. The difference is small, just fractions of a pound, but it's real. And it's all thanks to the Earth's shape, its rotation, and a force you feel every single day but probably never notice. So, how does the spin of our planet make you lighter? And why doesn't it fling us all into space like a spinning carnival ride gone wrong? Let's start with a simple question. What is weight? Most people think it's just how heavy you feel or what the scale says. But technically, your weight is the force of gravity pulling you down toward the center of the Earth. That's why you can jump higher on the moon or feel lighter underwater. Different forces are at play. Now here's where things get weird. Earth isn't a perfect sphere. It's more like a slightly squished ball, what scientists call an oblate spheroid. This shape means that the equator bulges outward and the poles are flatter. Add Earth's constant spinning to the mix, and you've got a recipe for uneven gravity. The centrifugal force, created by Earth's rotation, acts against gravity, reducing the pull you feel at the equator. It's subtle but measurable. But why does Earth spin at all? What does its rotation have to do with a few ounces of difference in your weight? And could this strange fact ever affect your life in any significant way? Here's the thing. Gravity is a constant, right? It's what keeps your feet planted on the ground and makes objects fall. But what if I told you that gravity doesn't feel the same everywhere on Earth? In fact, depending on where you are, it's not just the pull of gravity that changes. There's an opposing force trying to counteract it. The centrifugal force, created by Earth's rotation, is strongest at the equator and weakest at the poles. This means gravity has to work harder to keep you grounded at the equator than it does at the poles. That's why you weigh less in places like Brazil or Indonesia compared to Norway or Antarctica. It's not because you've burned off calories. Sorry, no free weight loss tricks here. It's because the forces acting on you are slightly different. But there's more to this story than just numbers on a scale. Could this small difference in weight have an impact on industries, scientific research, or even space exploration? And what happens if the Earth's rotation ever changes? First, let's talk about the Earth's shape. Why is it squished? The answer lies in centrifugal force. When Earth spins, everything on its surface is flung outward, much like how water in a spinning bucket pushes against the sides. This outward push causes the equator to bulge and the poles to flatten. Now, let's look at how this affects gravity. At the poles, you're closer to the center of the Earth, meaning gravity pulls on you more strongly. At the equator, you're farther from the center, so gravity's pull weakens slightly. On top of that, centrifugal force acts like a small upward push, further reducing your weight at the equator. Here's a real-world example. If you weigh 150 pounds at the poles, you'd weigh about 149.7 pounds at the equator. It's not a huge difference, only a few ounces, but it's enough for scientists to take notice. GPS systems, satellite calibrations, and even sports like high jump competitions can be influenced by these variations. But it gets even more fascinating when you think about what happens as you move away from Earth. For astronauts in orbit, centrifugal force and gravity find a delicate balance, creating the sensation of weightlessness. On the surface, though, these forces work together in a much subtler way to shape our everyday lives. Now, here's the mind-blowing part. What if Earth spun faster? If our planet's rotation sped up, centrifugal force would increase, and we'd weigh even less at the equator. In extreme scenarios, it could even overcome gravity, making it impossible to stand on the surface. Think about that, a world where the ground literally couldn't hold you down. But before you panic, don't worry. Earth's rotation is actually slowing down very gradually, thanks to the gravitational pull of the moon. Millions of years from now, days will be slightly longer, and the difference in weight between the equator and the poles will shrink. Still, the idea of centrifugal force playing such a crucial role in your weight is a reminder of just how dynamic and interconnected our planet is. So the next time you step on a scale, remember, your weight isn't just about gravity. It's shaped by the Earth itself, its rotation, its shape, and the forces at play beneath your feet. The equator's slight weight reduction might not help you fit into smaller jeans, but it's a fascinating glimpse into how physics shapes our everyday lives.